Okay, question 5. So we have a random survey of 600 registered voters, and we see that 39% actually voted in the last primary election. So what they're interested in doing is to figure out a population proportion of registered voters who actually voted. So out of that sample, we're trying to make some inferences or trying to make some decisions about voting in the entire population. So we want to find out the margin of error for a 92% confidence interval for the true proportion of voters, registered voters who actually voted. All right, so we'll start out here. We know that our population is 60, and then so we have this p hat value, and p hat value is the percent, right, or the proportion of our sample. And so in this case, it's 39%. So it's going to be 0.39. Okay, we know that we have a confidence level interval, right, of 92%, and that represents a z-score of 1.75. Okay, so a z-score of 1.75. And again, we can get this from a table, or we can look it up in an inverse function or something like that. So there's a couple of ways of finding that, but we're looking at the z-score for the confidence interval. Okay, 92%. So if we look that up, we get 1.75. All right. So the equation that we're going to use here, we're going to use the margin of error, right? So a margin of error is going to be, and the equation here is z times, and then it's p hat, right, which is 39% here, and then it's times 1 minus p hat. Okay, so this is the population of people who actually voted, and this is the population of people who did not vote, and then we're going to divide that by our sample size n. Okay, so in this case, we're going to get 1.75 times, our p hat is 0.39, 1 minus our p hat, so it's whatever's left over, that's going to be 61, so 0.61. And then our population here is 600. Okay, and if we calculate that out, we get 0.03484, which is about 3.5%. So margin error about 3.5%.